Hello and welcome to this presentation. Basically, a quick presentation on the notion of extending on the if decision construct within Java or programming in general to include more than one scenario. So what I'm looking at here is basically I'm using the scenario of a football scoreline, and we should all be fairly familiar. If not, it is an easy enough concept to understand even for people that don't, that if one team scores more than the other, that they obviously win. But if we had to implement the logic to help us decide that, or help the program to decide that, we would have to at least break down, okay, what would happen in our own mind and translate that into such a way that the programming language can interpret that. So looking here on screen, we can see that I've done up a quick scoreline. And obviously, as you can probably guess, yes, I'm an Inter fan. And obviously, I've just done up a hypothetical scoreline. Obviously, Inter would score more against Juventus. But basically, here it is the fact that Inter is 1 and Juventus is 0. Now, don't worry, I will be changing around the scenario. But realistically, when we see a scoreline, especially a football scoreline, our mind goes into kind of very, very quick action, and we don't even interpret the very, very basic steps of the decision process. So if we look up here, we do have a home team. Now I could put any name in there, but obviously I put in these two, and we've an away team name. Now obviously we could store them with strings and so forth, but I've got a home score and I've got an away score. Now basically there are three scenarios what can happen in a football match, football, soccer, or whatever, is that if the home team scores more than the away team, the home team wins. The second scenario, obviously, is that if the away team's score is greater than the home team's score, the away team wins. And the third scenario is that if both scores are equal, okay, obviously if I put there, if it ended 0-all, both scores are equal, so therefore it would be a draw. Now, if you were interpreting that in your mind and you're calculating that, you would have at least to look and make your decision on, was there two of those scenarios tested? Did we test that either for two of those scenarios, and if they were both false, then obviously it must be the third scenario and we don't even need to test for it. Now, what we should be doing obviously is that you should be talking about writing some of your code in what's known as pseudocode. Basically, as I said there, the steps that we have to do and kind of say, okay, hang on a second, these are the general steps. So if I can translate them down and then fit them into the context of the programming language. Now, some of the steps you may not be able to do. Like one of the steps that comes to mind is that, let's put it this way, the simulation of shaking a dice and producing whatever outcome of that. That is just, for want of a better word, I would always suggest is a kind of a blue sky scenario. I.e., why is the sky blue? It's just blue. In other words, that there is a one line given that will produce a random number, and that random number will be between 1 and 6. It's one of these things that you just learn off. You can look at the intricacies of it, but that's later. That's kind of a scenario where you kind of have to say, okay, look, listen, I can't break that down to its very, very, very bare minimum, but at least I know the general concept of where we can get it. Now, looking at this one here, so even if I was to go like pseudocode, you're testing if, let's put it this way, the home score, actually an easy way than this is that I increase the font, okay. If I increase the font, let's just say to about 20, okay. If home score is greater than away score, I know, okay, on a new line, I'll tab it in, tab it in to show that this is, if the above thing is true, okay, I know that the home team won. Okay. Alternatively, we could put in another if away score is greater than home score. We know that the away team has won. Okay. Now obviously all I'm doing here is pseudocode. It's what's known as a high level language. It's not even a language, but it's a high level typing that people should be able to, no matter what language they use, interpret it and then translate it into either Java, Python, C++ or whatever. So the third eventuality, okay, is obviously we don't even did the test. But before we come to that, okay, these two are actually two kind of statements on their own. This if is different to this if. But if we want to think of it even logically, we kind of say, if it's not this, else it must be this. Right? In other words, not testing both of them, one independent of the other. In other words, this one is separate from this one. We're going to test this one, and then if that's not true, we're going to test this one. So in programming, realistically, all what you have to do, and even think of this logically, you would use something like else. Okay, else if the first situation is not true, if this is not true, okay, then we'll test this one. Now also notice this, and I'll just do something here. Okay, very, very small, but very, very significant. Anything in the red is the actual test, is an actual test. Okay, and if that is true, if that test is true, it then does the statement right afterward. It's in this case that the home team won. In this case that the away team won. Okay, so then the third thing is that if it's not going to be a home win, if it's not going to be an away win, it obviously must be a draw. Now here's the thing, do we need to test for that? Now you could say, yeah, we could. What's the problem about that? There's no problem. But alternatively, you could say, look, if neither of the first two scenarios takes place, obviously the third one must. In this case, 3 scenarios, one of them must occur. Okay? Now I'm not saying, okay, obviously you'll get some tickle, oh, the match was abandoned. No. In this situation, that you either get a home team, an away team, or the draw. Okay? Now more importantly then, is just putting in a few things here, pseudocode. So this is the pseudocode, right? This is what's known as pseudocode. That you should be able to take this and use it as planning for when you implement your own code or your interpretation of the code. Now also too, in relation to this, okay, is I just want to increase this a tiny bit, you know what I mean, to make it kind of there. Okay, the sort of pseudocode. Okay. But even before any of this happens, obviously we'd store things in variables. Now, somebody might ask me, would it be possible to do it the other way about? If the away score is less than the home score, yes, it is fine. And I'm not just saying that my interpretation of it is the right way. No. There'll be plenty of interpretations of a scenario, but what you must do is at least interpret one correct one. Getting the code then to work completely right is very, very difficult. And what you should always do is when you are testing it, which you must, test it incrementally. In other words, okay, we'll just do this situation first. Okay, so if I put in this situation, and if I have a variable to store my home score, and a variable to score my away score, and I've only implemented the first if of the whole thing, I shouldn't even see a print statement. It won't, the two scores are equal. So this if statement won't be legitimate at all, or won't be effective. Even with the second one in, it won't be effective. But most importantly is this is that you see that that is happening. And then you build on your code to take care of that third scenario, in this case a draw. Okay? So what I'm going to do here now is, I will obviously include this with the video, but I do think that you should take scenarios that you know and then work them through. Before I obviously implement this, I want to just obviously explain that all of these will be stored in variables. Now you might need the home team name and the away team name. You could store them in strings if you did need them, okay? But definitely you would need a variable to score the home score and the away score. Whether you input that variable or you hard code it, i.e. just put in a variable and assign a value straight there and then, you would still need a variable for that. And in terms of that, okay, it's a whole number, so you would need either an int, okay, or let's just say a byte. A byte would be more applicable because you would never assume that a match scoreline will go above 127. Okay, but if it does, obviously a byte would be useless. Okay, if it was a cricket scoreline where you're taking the runs into account, you would need something over the capacity of a byte. But obviously int is okay because you're only using two of them. Now what you could do obviously is that you'd have an int to hold the home score and the away score. And a different interpretation could be just the difference between them both and use that as your basis for the if test. But an if else is, to the core of the video, is the basis of deciding where there's more than one outcome possible in a scenario. Now what I'll do now in the next few seconds is show this implemented on IntelliJ. Okay, welcome back to the video. I'm looking up at our code here, very simple code at the moment. We've got it in a class called matchResult. You can see it's within the main method, and we've only got two variables at the moment, two integers, one for home score and one for away score. And as you can see here, it's 1-0 to the home team. So realistically, the home team won. But as I said earlier, what we should be doing, and I just want to get rid of this here, what we should be doing is that we should be building it up incrementally rather than putting all our code in at once. Building it up incrementally, at least in checking if the part by part works. So what we need to use is an if statement, okay, and if, okay, home score, and you can see there that when you're typing out in IntelliJ, it will predict what you want, so we press return there, is greater, that is the logical or the mathematical operator for greater than, away score. Okay, right. Then in curly brackets, we're going to put in if that test, which is in round brackets, so whatever is in the round brackets is our test, but whatever is in the curly brackets then is that if that test is true. So in that case here, this test, in this scenario, it's true. So what we can do here is obviously just put in, okay, a simple printout, home team 1. Okay, so we will test this now in a few seconds. But again, there, as I said, a simple printout. We can build our printouts up, and I'll do a separate video for that to show by how much and whatever. But that's a different video. But this one now, obviously we need to recompile or build whatever. We will rebuild this one, okay? And even if you wanted to recompile it, just to be safe, okay? But if we run this, okay, run match result, you can see down here, home team 1. Now some of you who were very observative might have seen a printout, but that was from an earlier attempt at this, okay? So we've got this if, and it does actually work. But the one thing what you should always do is that, yeah, that tests if it's the positive, like we know we can see it here. But what if we said here, hang on a second, the away score is now 2. So the away team wins. And even though, okay, logically, we should not see any printout, it's a good idea to actually see, will we see a printout? We shouldn't see a printout because it's the only place here in the program that has a printout. So realistically, what we should be seeing is that the home score is less than the away score, so we shouldn't see the printout. So if I clicked on run match result there, okay, there is no printout or anything, but if it program finished with exit code 0, meaning the code has run. It's just that it hasn't included the scenario yet for the away team winning. So what we need to do then is incorporate that. Okay, now if you want your code obviously elegant and nice looking, yes, keep it nice and tidy. So in this case here, all I'm going to say is away score is greater than home score. Now we could have done it in the alternative way of saying if home score was less than away score, but I always like keeping my mathematical operators the same way, so at least then every one of the tests is kind of corresponding. So what I'll just do here is SOU2 again and away team. Okay, 1. So we'll rebuild that. Okay, we'll build this project, and okay, it's fine. So if I go there and then to run it, away team run 1, sorry. So that's okay. Okay, so what we need to obviously do is do a bit of testing here. Okay, 3, 2 to the home team, and run it again, and we should see, okay, that the home team won. Okay, so that's the 2 scenarios. But what would happen then, obviously, is that if it's 2 apiece, okay, it's a draw. Have we incorporated code in to facilitate that? And the obvious answer is no, but we must obviously check for that. So if I run this, okay, there is no printout. Now, I have to incorporate now something within this if-else if to cater for that. Now again, like previously that I said in the first half of the video, is that I could just put in else it's a draw, okay, and I think that would nearly be the best. Okay, else, okay, and even if you want to keep everything nice and clean, okay, SOUT and match is a draw. Okay, now in this case there, okay, what we obviously need to do is do testing for that again. Okay, so build the project, okay, and we run it again. Okay, matches a draw. So if I change just even to verify that again, okay, 3-2 to the home team, build or run it, we should see home team 1. Okay, and obviously tests for that. Now again, this is a very straightforward test, okay, but bearing in mind just a few important things here. Okay, I'm just getting rid of any free space or free white space that we kind of don't need too much. But it's a very, very simple program that all we're really doing is hard coding, and this is hard coding where you're putting in values into the actual code itself, as opposed to putting in data input, which I will show later. But we're hard coding in values and we're just testing them straight away. But we're not doing tests on the values themselves that, okay, supposing somebody put in -3 or 2.5 or something like that, what would happen in that situation? Okay, but this video was just simply, okay, a few things. Number 1, to show the functionality of the if, else, if, else, but also 2, to show that the importance of understanding the scenario and doing a tiny bit of planning in regards to that scenario in relation to your code. I will leave a few questions afterwards that I would like you to look at and, I suppose, contemplate and try and work out yourselves. Okay? And I will, as I stated before, in the next video, work at the notion of embellishing the printouts here to give it a bit more semblance or kind of meaning. Okay? So I thank you very much for your attention. Keep on coding, and we'll talk to you the next time. Take care.